Today we're going to look at difference quotients. A difference quotient is a mechanism where we can calculate the slope of a secant line. We look at that in college algebra as a preface for moving into calculus, where we will use difference quotients to find the slope of a tangent line. The formula for a difference quotient is we take a function, f of x, and we evaluate it at f of x plus h. We subtract f of x, and we divide by h. And here's where that formula comes from. When we take a graph, if we find 2 points on the line to make a secant line, we're going to call the first point x and f of x. The second point on this line we will call x plus h for the x value, and f of x plus h will be our y value. Now we've got 2 points. We can use the formula that we've learned for slope to calculate the slope of this secant line. The slope is going to be as follows. It'll be f of x plus h minus f of x. So that's y2 minus y1. We're going to divide that by x2 minus x1, so x plus h minus x. In order to get it to the final form, we'll simplify the denominator, where we have x plus h minus x. That's going to equal just x. I'm sorry, just h. So there's our formula, f of x plus h minus f of x divided by h. So we can take any function and we can apply this formula for a difference quotient to come up with the slope of a secant line. We'll look at a simple one first. This is a linear function. So we have f of x equals 3x plus 5. So we have a slope of 3, a y-intercept of 5. We'd like to use our formula. So wherever we have an x, we are going to substitute an x plus h. So there's f of x plus h. And then I subtract the original function, f of x, and divide by h. So at this point, we're going to just use basic algebra skills. We'll distribute, combine like terms, and simplify as much as possible. So in the top, we'll get 3x plus 3h plus 5 minus 3x minus 5, and it's still all divided by h. When you get to this stage, there should be several items that will cancel. So the 3x's and the minus 3x and the plus 5 and the minus 5 will all cancel. We'll divide what's left by h, and we end up with 3. So the slope of a secant line for this function, 3x plus 5, is going to equal 3. It will equal 3 all the time, and we kind of knew that ahead of time, right? Because the slope of a line never changes. It's always going to be 3. That's not going to be so when we look at curves. So as we move on to the problems, we will see that we end up with an equation or a function rather than just a constant value. Looking at the second example, we now have a quadratic equation, x squared plus 5x plus 3. We'd like to apply or find the difference quotient. So we substitute x plus h wherever there was an x. So that would be f of x plus h, and then we subtract the original function, f of x. So that's x squared plus 5x plus 3. Still dividing by h. Now, because these are a little more complicated, we have to do some foiling, distribution, combining like terms, so it's a little bit more complicated. But it's not stuff that we haven't done already. So we get x squared plus 2xh plus h squared. Second one, distribute, we get 5x plus 5h plus 3. Then distribute our negative, we get minus x squared minus 5x minus 3. All divided by h. Again, this is the stage where we can cancel many terms. So we have x squared and a minus x squared. We have a 5x and a minus 5x and a 3 and a negative 3. That leaves in the top 2xh plus h squared plus 5h. We're going to divide each of those terms by h, and we end up with 2x plus h plus 5. So that equation will give me the slope of a secant line given any x value, and h is going to be some arbitrary distance to the right of h, or to the right of x. So my slope of my secant line here is going to be 2x plus h plus 5. Next example is also a quadratic, but this one now has a coefficient of 2 in the front. So using our formula again, we get 2 times x plus h squared plus 3 times x plus h minus 1. And we're going to subtract f of x, so that's minus 2x plus 3, 2x squared plus 3x minus 1, all over h. Same distribution, so anything that has a quadratic in it is going to expand the same way. So here we'll get 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus the 1. Then we'll subtract that original, minus 2x squared minus 3x plus 1, all over h. At this stage, we can cancel things, so we cancel 2x squareds, 3x's, and the 1's. Divide what we have left by h, and the result is 4x plus 2h plus 3. That would be the slope of our secant line. Next, we have x cubed minus 1. So when we get to the cube functions, those are a little bit more challenging because we now have to expand a cube. We'll show you a bit of a shortcut in a bit. So we have x plus h cubed minus 1. So that's f of x plus h, and then minus x cubed plus 1. That's minus f of x dividing by h. So when we expand this, you can do x plus h squared and then multiply that by x plus h again, but we'll show you a shortcut using the binomial expansion using Pascal's triangle shortly. So here we're going to get x cubed plus 3x squared h plus 3xh squared plus h cubed minus 1 minus x cubed plus 1, all divided by h. This is the cross cancel point. We x cubes cancel, the 1's cancel. We have 3x squared plus h plus 3xh squared plus h cubed over h. When we do that division, we end up with 3x squared plus 3xh plus h squared. That's going to be our secant line. So the slope of the secant line here is going to be 3x squared plus 3xh plus h squared. And then as a preface to what we'll look at next, let me give you just a glimpse into what's called Pascal's triangle. So we start with 1. The next row would be 1 and 1. Once we get to the next row, we'll have a 1 on the outside. So the 2 in the middle is the sum of the two numbers right above it. And then we have a 1 on the outside at the end. For the fourth row, we have a 1 on the outside. 1 plus 2 is 3. 2 plus 1 is 3. And then a 1 on the outside. So when we expand a cubic function, the coefficients are going to be 1, 3, 3, and 1. And this is called Pascal's triangle. We use that to do binomial expansion, or the coefficients of a binomial expansion. And we'll tell you a little bit more about that in another video.